Hello everyone, you're welcome back to this channel. In this video, I'm going to solve this question I have on the board. The question says a box with dimensions as shown below is placed on a flat surface. We increase the magnitude of the pushing force until the box tip over or begin to slide. Which will occur first? Assume the center of mass of the box is at the center point of the box. So we have this box here, and then we are applying a push force P to the box. The question is asking us to determine whether what the box will tip first, which is what rotate, or slide first, which is what move horizontally in the direction of what the applied force. So let's look at which of these two cases what will occur first. So to determine which of these two cases will occur first, what you're going to do is that you are going to calculate for the minimum force required for sliding to occur, and then you also calculate for the minimum force required for tipping to occur. Then you compare these two values. The smaller value will tell us which of the two cases what will occur first. So let's look at how you are going to do that. So I will start by calculating for the minimum value required for sliding to occur. So let's look at that. I will draw a free body diagram for the system. We have the weight force here. Then you're going to have a normal reaction due to the surface, right? So let's calculate for the weight force. That will be equal to 60 kg times 9.81, which will give us 588.6 newtons as the weight force. And then we have the applied force here. Okay. And we are going to have the friction force here, which is due to these two surfaces in contact. Okay. All right. So now this system is actually in equilibrium now. Okay, so what that means is that the weight force is being balanced by the normal reaction force, and then this applied force P here is being balanced by this friction force here. Okay, so we want to calculate for the minimum value of P that will cause the box to begin to slide. Okay, so that value will have to be equal to the maximum friction that's what we present here. So for us to be able to tell the value of P, we just have to calculate for the maximum value of friction. Okay, so let's look at that. The maximum value of friction will be equal to the coefficient of static friction, times the normal reaction force. Okay, all right. So let's look at how you're going to do this. This value is already given to us as 0.61. What about the normal force? The normal force is balancing the weight force. So the normal force will be the same as the weight force, but it will just be in an opposite direction. Let's keep that in mind. So the normal force will also be 588.6 newtons. So we're going to have our F max to be equal to 0.61 times 588.6. So let's see what you're going to get. 0.61 times 588.6. That gives us a value of 359.046 newtons. Okay, so this is the maximum friction that will be present due to these two surfaces in contact. Okay, and before the box will start sliding, this P value here must be equal to this value here. Okay, so P will be equal to 359.046. Okay, so now before sliding will occur, P must be equal to this value here. So therefore, this becomes the minimum value that P must be in order for sliding to occur. Okay, so in order for sliding to begin to occur, P must at least be equal to this value here. At the point where we get P to be equal to this value, that means sliding is about to begin to occur. If we increase this value any longer, then sliding will occur freely. So this is the least value that we need in order to cause this box to begin to slide. So now let's calculate for the minimum value that we need in order to cause the box to begin to tip. Then we compare it to this value, and then look at which of them that is smaller, and then that will tell us which of the cases will occur first. Let me write this here. P is equal to 359.046 newtons. All right, so now let's look at the tipping key. So that one, so let's draw the free body diagram. Okay, so we're going to have the weight force here, which is 588.6 newtons, right? And we have what the normal reaction force here. Okay, and then we are going to have what the friction force here. Okay, so for tipping, the normal reaction will be concentrated at what the point of rotation, and then same for the what friction force. Okay, so both the normal reaction force and then the friction force will be concentrated here. Okay, and then I'm going to have the pushing force here. You have the distance to be 3 meters, so half of it, okay, will be 1.5 meters, right? Okay, and then you have this distance to be 3 meters also. Okay, so now we want to apply for the what minimum value of P that is required for what taping to what. Okay. So to do that, what you're going to do is that you're going to what calculate for the what the moment, okay, that will be caused by what this P here, about this point here, okay, and then equate it to what the moment that will be caused by what the weight force about this point here. Okay, the reason why we are doing this is because taping will begin to occur the moment that what the moment caused by what this pushing force is equal to the moment caused by what the weight force. Okay, so as soon as the moment caused by this pushing force is equal to the moment caused by what the weight force, then that means what tipping is about to occur. So to determine this value of P here, we are going to what calculate what the moment that will be caused by what this P here, okay, and equate it to what the maximum moment, what that will be caused by what the weight force there. Then we solve for what the value of what P, and then that P value will be what the minimum value that we need in order what for tipping to begin to what to occur. So we are going to calculate the moment, okay, that will be caused by what this P here, and then that will be what P times these 3 meters here, and then okay, that should be equal to the moment caused by what the weight force. That would be what 588.6 times what 1.5 here. Okay, so the moment or at the point where the moment caused by what this P here is equal to the moment caused by the weight force, then that means that what tipping is about what to occur. That's why we are equating this. So the P value here will be the minimum value of P that we need in order for tipping to begin to occur. Okay, so at that point, if we increase P any longer, you see that what the value we have here will be bigger than what the value what we have here, right? So that means what tipping is what is occurring. So this is the minimum value of P that we need in order for tipping to begin to occur. So now let's calculate for this value here. So we're going to have 3P equals 588.6 times 1.5. This will give us a value of 882.49. So let's divide both sides by 3. So this will cancel out this. So I'm going to have P to be equal to 882.9 divided by what? 3. That gives us a value of 294.3 newtons. Okay. So what this means is that before tipping will occur, P must be equal to what? This value here. Okay, because as soon as P is exactly equal to this value here, then the moment that will be caused by this value will be equal to what? The moment that will be caused by what? The weight force, right? So at that point, if you increase P any longer, the moment that will be caused by P will be greater than what the moment that will be caused by what the weight force, then the box will tip freely. Okay, so this value here becomes what? The minimum value of P that we need in order for tipping to begin to occur. So you have P, let's name it P tip, and then P sliding. So that's equal to 294.3 Newton. Okay, so you can see that PT is less than PS, right? Which means that the force required for tipping to occur is less than what the force required for sliding or to occur. So as we keep increasing the force, we are going to get to this value first before we get to this value. So that tells us that what tipping is going to occur before if sliding will occur, then it will also occur. You get it? So now we can tell that what within these two cases, the box is going to tip first. Okay, so that's how to go about this type of questions. Thank you very much for watching this video. Make sure you like the video and then subscribe to the channel if you haven't.